Hello, my dear friends. How are you all? I hope you all are fine. So you are very welcome in our lecture number third of surface areas and volume. Okay. So today we are going to discuss a lot of problems. Okay, based on surface area of cube and cuboid. Okay, my dear friends. So this lecture is very important, and you have to be listen very carefully. Yes. So now, first of all, let's let's revise the formulas. Okay, now here is first of all we are going to discuss about cuboid. Okay, in cuboid we know that total surface area is what? Total surface area is equals to, we know that this is 2 into lb plus bh plus lh. This is what? This is the total surface area of cuboid, or we can say TSA. Okay, and lateral surface area, lateral, lateral surface area, or we can say LSA. So in this case this is what? 2h into L plus B. What is 2h into L plus B? Here L, B and H are what? Length, breadth and height. Length, breadth and height. Now in cube. So let's talk about the cube. So here is TSA, means total surface area is what? 6A square. A is what? A is side. Okay, here we are assuming that A is side of the cube. Side of cube. Now LSA is what? LSA is, here is LSA is 4A square. What is? Yes, 4A square. I hope you get this point, my dear friends. Now let's solve problems. Yes, so the question number 1 here is a plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep. 65 centimeter deep is to be made, and it is to be open at the top. Okay, ignoring the thickness of the plastic sheet. Now determine the area of the sheet required for making the box. Okay, let's suppose this is a box. Okay, and the open part means the top part is open, means there is no sheet in the top part. Okay, and here is we have length is L is 1.5 meter. Breadth is, here is, you can see, breadth of box is 1.25 meter, and height of the box is 65 centimeter. Here is, you can see, this is 65 centimeter and we have to convert it into meter, so we have to divide by 100. Okay, so here we get, if we divide it by 100, here we get 0.65 meter. What is? Yes, 0.65 meter. Okay, I hope you get this point. Now the area of this required sheet is what? Area of this cuboid minus area of top part which is open, means we have to subtract the area of this open part from the area of total cuboid. Okay, yes, so now here is area of sheet required is equals to, here is, you can see, area of cuboid minus area of top, which is what? Which is open. Okay, so now here if we applied the formula, area of cuboid is what? We know that this is 2 into LB plus BH plus LH minus, here is area of top bottom, which is what? Which is in the shape of rectangle, And what is the formula of area of rectangle, which is L into B, means length into breadth. So here is L into B. Now apply the, now put the values in this formula. So here this will become like 2 into L, we have L here is, you can see that 1.5 into 1.25. Okay, now here you can see plus B 1.25 into 0.65 plus here L is 1.5 into 0.65. Okay, minus here is L into B. So L is what? L is 1.5 into B is 1.25. 1.25. Okay, I hope you get this point, my dear friends. Now here is, you can see, so here is, this will become, if we solve this, we get 3.6625. So 3.6625 minus here is, so here this will become like, if you solve this, here is 1.875. Okay, 1.875. So if we multiply this part, we get 7.325 minus 1.875. So after solving this, we get 5.45 meter square. So this is what, this is the area of sheet required. Okay, so this is the answer of this first part. This is the answer. Now in the second part, the cost of sheet for it, if a sheet measuring 1 meter square costs rupees 20. Okay, so we have to find the cost. Okay, we know that the area of sheet required is what? Area of sheet required is 5.45 meter square, and the given is cost of sheet per meter square area, per 1 meter square area is rupees 20, and cost of sheet, okay, cost of sheet of 5.45 meter square area. So this will be what? This will be, here is rupees 5.45 into 20. So this is equals to rupees 109. So the cost is what? 109 rupees. So this is the answer of this question. Okay. Yes, let's move on to the next question, which is the length, breadth and height of a room are 5 meter, 4 meter and 3 meter. Okay, we have L, B and H respectively. Find the cost of whitewashing the 4 walls of the room. Whitewashing the 4 walls of the room and ceiling. We have to whitewash the 4 walls of the room and ceiling, and the cost is what? The cost is the cost of whitewashing is 7.50 rupees per meter square. Okay, so for this, first of all, for finding the cost of whitewashing, first of all we have to find the area. We have to find what? Yes, we have to find the area of this part. Yes, so first of all, let's write the given part. So here is, we have length means L of room. Length of room is what? Length of room we have 5 meter. Okay, and here is breadth means B of room. Breadth of room is 4 meter, and height means H of room. Height of room is 3 meter. Okay, understand? So we have to whitewash the 4 walls and the ceiling of the room. Okay, so here is the area to be whitewashed. The area to be whitewashed is is equals to area of cuboid minus area of base and we know that area of cuboid is what? Area of cuboid is 2 into LB plus BH plus LH minus this will be L into B. Okay, and if we multiply 2 in the bracket, so we get 2LB plus 2BH plus 2HL, okay, or LH minus LB. Here we have 2LB and here is single LB, so we can write here as LB plus 2BH plus 2LH. Okay, now put the value of L, B and H in the formula. So here we get, so area to be whitewashed. So this is equals to, we are putting the values. So here this will become like 5 into 4 plus 2 into 4 into 3 plus 2 into 5 into 3. Okay, so this will become like 20 plus 24 plus 30. So after solving this, here we get 74 meter square. So the total area is what? 74 meter square. What we have done, so from this cuboid, from the area of the cuboid, we are subtracting the area of this base, which is in the form of rectangle. So now we have cost of whitewashing for 1 meter square area. So this will be what? This is what? Rupees 7.50. So here is cost of whitewashing for 74 meter square area, so this is equals to 74 into 7.50. so here we get, after solving this 7.50, after solving this we get 555, means 555 rupees. Okay, so this is the total cost of whitewash. I hope you get this point. Yes, so the next question here is, you can see the floor of a rectangular hall has a perimeter 250 meter. If the cost of painting the 4 walls at the rate of 10 rupees per meter square is 15,000 rupees. Now find the height of the hall. We have to find the height of the hall. Here is a hint that area of the 4 walls is equals to what? Lateral surface area. It means area of the 4 walls means, in the cuboid we are excluding the top and bottom part. Okay, means top of hall and floor of hall. Okay, I hope you get this point. Now first of all, here is, we are assuming that length, breadth and height is length, breadth and height, of the rectangular hall, which is in the form of cuboid. Rectangular hall be L meter, B meter and H meter respectively, Got it? So we know that here is perimeter of the floor hall is what? Here is we have the perimeter of the floor hall, which is 250 meter. So perimeter of the floor of hall, this is equals to, we know that this is 2 into L plus B, and 250 meter is equals to 2 into L plus B. So my dear friends, here is L plus B is equals to 250 divided by 2. This will be 125. This is what? 125. Let's suppose this is equation number 1. This is equation number 1. So now my dear friends, here is area of 4 volts. Area of 4 volts. This is equals to, it is given in the hint that area of 4 volts is equals to lateral surface area. Is equals to lateral surface area. And what is lateral surface area? We know that this is 2 into H L plus B. 2 into H L plus B. It means 2H into L plus B is what? Here is from equation number 1. From equation number 1, this is 125. This is 125. We can write from 1, from equation 1. So now this will become, here is 250H meter square. So this is what? This is the area of 4 volts. So area of 4 volts is equals to 250 H meter square. Now cost of painting per meter square area is 10 rupees. So we have cost of painting for 1 meter square area is equals to rupees 10. What is? Yes, 10 rupees. So here is cost of painting, okay, of 250 H meter square area. So this will be what? 10 into 250 H, and we have the total cost. So this is given in the question that the total cost is 15,000 rupees. What is 15,000 rupees? It means this value, this is what? This is in rupees. It means this value is equals to the, yes, 15,000. So this is equals to 15,000 is equals to 10 into 250H. 10 into 250H. So H is equals to 15,000 divided by 2500. This 20 and this 20 will be cancelled. Okay, and we can cancel 150 by 25 as 6 times. That is 6 times. So here we get H is equals to 6. Yeah, H is equals to 6 meter. So this is what? This is the, yes, height of the hall. So this is the answer of this question. I hope my dear friend you understand these things. Yes, so now let's move on. Okay, so the next question here is, the paint in a certain container is sufficient to paint an area equal to 9.375 meter square. So how many bricks of dimension 22.5 centimeter, 10 centimeter into 7.5 centimeter can be painted out of this container? Okay, so we have a bricks of dimension is, length is 22.5 centimeter, breadth is 10 centimeter, and the height is 7.5 centimeter. So we have to find that number of bricks that can be painted out of the container. Okay, so here you can write it as number of bricks that can be painted out of the container. Okay, so this will be, this is equals to area that can be painted, by the container. Okay, and here is divided by surface area of bricks, means total surface area of bricks. So we can write surface area of bricks. surface area of bricks. I hope you get this point, my dear friends. So now here is, we have a dimension, we have a unit of dimension in centimeter, okay, and the unit of, yes, unit of area is meter square. So we have to convert, either you have to convert this meter into the centimeter, or you can convert these centimeters into meter. Okay, so for comfortability, we are going to convert this area, the unit of this area, into centimeter. Okay, so now my dear friends, here is area that can be painted by the container, by the container. So this is equals to, we know that 9.375 meter square. Okay, if we convert it into the centimeter, then here is 9.375 into, we have to multiply 100 two times. Okay, so this will become like 100 square, it means 10 raised to power 4. After solving this, here we get, if we remove the point, here we get 1000. So these 3 zeros will be cancelled, so we get 93750 centimeter square. So this is the area that can be painted by the container. Okay, yes, so now here is, we know that TSA of one brick means total surface area of one brick is equals to 2 into LB plus PH plus HL. So now my dear friends, here will become 2 into LB, is it means 22.5 into 10 plus 10 into 7.5 plus HL means 7.5 into 22.5. I hope my dear friend you understand these things. So this will become 2 into 468.75. So after solving this, here we get 937.5 centimeter square. What is? Yes, 937. Okay, 937.5 centimeter square. Okay. Okay, so here is, now we have to put the values of in this equation. Okay, so area that can be painted by the container is what? 93750, and surface area of bricks is what? 937.5. So here is number of bricks. Number of bricks can be painted out of the container is equals to 93750 divided by, here is, divided by 937.5. If we remove this point, here we get 10 in the numerator. Okay, so this and this will be cancelled by 10 times. So 10 into 10 is what? 10 into 10 is 100. What is? Yes, 100. So 100 bricks can be painted out by the paint of the container. So we can write here as, since it means 100 bricks. What is? 100 bricks can be painted out by the paint of the container. Okay, yes, so now my dear friends, here is, now let's move on. Yes, next question states that, here is, a cubical box has each edge 10 centimeter and another cuboidal box is 12.5 centimeter long, 10 centimeter wide and 8 centimeter high. Here we have cubical box and another cuboidal box. We have two boxes. One is cubical box and the other is cuboidal box. And the dimension of cubical box is 10 centimeter. What is? 10 centimeter, and the dimension of cuboidal box is 12.5 centimeter long, 10 centimeter wide, and 8 centimeter height, means length, breadth, and height. Okay, which box has the greater lateral surface area and by how much? So first of all we have to find the lateral surface area of both the figures. Now here is edge of cube. We have edge of cube which is equals to a. Let's suppose we are taking this is a, which is equals to 10 centimeter. What is 10 centimeter? And length of box L of cuboid. We can write length of box means L is equals to 12.5 centimeter, and breadth of box which is B, this is equals to 10 centimeter, and height of box like H, this is equals to 8 centimeter. Now lateral surface area of cubical box means this box. Here we can write lateral surface area of cubical box is equals to, we know that this is what, 4 into a square. What is 4 into a square? And a is what? A is 10. It means 4 into 10 square. This is equals to 400 centimeter square. Okay. Now lateral surface area of cuboidal box. Lateral surface area of cuboidal box. So this will be, this is equals to, we know that this is 2 into H L plus P. Okay. So 2 into H is what? H is 8. 2 into 8 into L plus B means L we have 12.5 plus B we have 10. So this is 16 into, this will become 22.5. 22.5. So after solving this we get 360 centimeter square. Okay. Okay. Yes. So now if you observe these two values, we can say that lateral surface area of cubical box is greater than lateral surface area of cuboidal box. Okay. So here we can write, so lateral surface area of cubical box is greater than lateral surface area of cuboidal box Okay, my dear friends. And how much greater? So this will be like 400 minus 360. After solving this we get 40 centimeter square. So therefore lateral surface area of cubical box is greater than the lateral surface area of cuboidal box by 40 centimeter square. So therefore we can say that, therefore LSA of cubical box, okay, LSA of cubical box is greater than LSA of cuboidal box by 40 centimeter square. I hope you get this point, my dear friends. So the next part is, which box has the smaller total surface area and by how much? Now we have to find TSA. We have to find what? TSA. Okay. Yes. So now let's find that. So now here is TSA of cubical box. So this is equals to, we know that 6a square, and a is what? 10. So this will become 6 into 10 square. So this is equals to 600 centimeter square. And TSA of cuboidal box, this is equals to 2 into LB plus BH plus HL. Okay, now put the values of L, B and H. So here we get 2 into 12.5 into 10 plus 10 into 8 plus 12.5 into here is 8. After solving this, here we get 2 into 305. So this is equals to 610 centimeter square. 610 centimeter square. So we can say that by observing these two values, we can say TSA of cuboidal box is greater than the TSA of cubical box by 10 centimeter square. So okay. So we can write TSA of cuboidal box. Cuboidal box is greater than the TSA of cubical box. Okay, and this will become like 610 minus 600. This is equals to 10 centimeter square. Okay, so therefore we can say therefore we can say TSA of cubical box is smaller than the TSA of cuboidal box by 10 centimeter square. Okay, I hope you get this point. Yes, so now my dear friends, here is, so the next question is, Praveen wanted to make a temporary shelter for her car. Okay, Praveen wanted to make a temporary shelter for her car by making a box-like structure with tarpaulin that covers all the four sides and the top of the car. Okay, now with the front face as a flap which can be rolled up. Okay, now assuming that the stitching margins are very small and therefore negligible, how much tarpaulin would be required to make the shelter of height 2.5 meter with base dimension 4 meter into 3 meter? Okay, so you can see here is, this is the box like this. This is the cuboidal box. Okay, this is what, this is the shelter for the car, and the bottom of the car, okay, which is not covered, which is uncovered, like this you can see. Okay, so first of all, here is length of, means L, of shelter. Length of shelter is what? Length of shelter is equals to 4 meter, and breadth of, means the breadth of shelter is 3 meter. Okay, and height, means H of shelter is 2.5 meter. Okay, and we need to find the area of cuboid shelter. Here shelter covers the four side of the car and the top of the car, and bottom is uncovered, and the bottom is what? Uncovered. So we can write area of tarpaulin required, is equals to area of cuboid minus area of bottom. Means we have to subtract the area of bottom from the area of this cuboid. I hope you understand these things, my dear friends. Okay, so the of tarpaulin area of area of tarpaulin required is equals to 2 into LB plus BH plus HL minus L into B. Okay, so this will become 2LB plus 2BH plus 2HL minus LB. We have here is 2 LB and 1 LB, and if we subtract this we get single LB plus 2BH plus 2HL. Now put the values here we get. So after putting this, 4 into 3 plus 2 into 3 into 2.5 plus 2 into 4 into 2.5. Okay, so this is equals to 12 plus 2 into 7.5 plus 2 into 10. So this will become, here is 12 plus 15 plus 20. So after solving this we get 47 meter square. We get what? 47 meter square. So therefore we can write 47 meter square tarpaulin. 47 meter square tarpaulin will be required. Okay, so this is what? This is the answer of this question. Okay, my dear friends, I hope you understand these things. Yes, so now my dear friends, so the next question here is, the total surface area of a cube is 726 centimeter square. Okay, now we have to find its age. We have to find the age of cube. So this is very easy question, my dear friends. Okay, so here is, we know that TSA of cube is 726 centimeter square. Okay, this is given, and TSA of cube is, we know that this is 6a square, and a is what? A is the age of cube, and this is equals to 726. Now from this, a square is equals to 726 divided by 6. After solving this, here we get 121. Okay, and here is, so we have a square is equals to 121. Now we have to find the value of a. It means take under root both the sides. So we get a is equals to 11 centimeters. So we can say hence the age of cube is 11 centimeter. Okay, I hope you get this point. Yes, so now my dear friends, so the next question here is, now find the ratio of the total surface area and lateral surface area of a cube. Okay, and here is, we know that TSA means total surface area of cube is what? Total surface area of cube is 6a square, and a is what? A is the age of cube. Okay, and LSA means lateral surface area of cube is equals to 4a square. What is? Yes, it is 4a square, and we have to find the ratio. So the ratio of TSA and LSA. So this will be, here is, you can see 6a square divided by 4a square. From this, a square and a square will be cancelled. From this, 4 can be divided by 2 times, and 6 can be divided by 2 3 times. So we get 3 upon 2. So the ratio is what? So here is ratio of TSA and LSA. Here you can see TSA and LSA is, yes, 3:2. What is? Yes, 3:2. Okay, my dear friends, I hope you get this point. Yes, so now my dear friend, this is enough for today, and we will meet in the next lecture with the next amazing topic. Okay, so thank you very much for listening me, and take care and goodbye.